Hello, my dear friends. Myself, Dr. Sandeep Jagdale, working as assistant professor at Pimpri-Chinchwad College of Engineering, Nigri, Pune. In the previous class, we discussed about the impurities present in water and how to determine the hardness of water sample by using the EDT method. In this lecture, dear friends, we are going to discuss what is alkalinity of water sample and how it is determined by using the titration. So first question is that what is alkalinity? So, dear friends, natural water is free from any type of impurity, rainwater. But when that water come on the earth and when it's journeyed on the earth, it may come in contact with the different types of salts, and in that way, the different salts get incorporated into the water sample, and they causes the hardness and alkalinity. The natural water may be alkaline due to the presence of hydroxides, bicarbonates, and carbonates compounds dissolved in water. Hydroxides such as ammonium hydroxide, calcium hydroxide, bicarbonates like calcium bicarbonate, magnesium bicarbonate, iron bicarbonate, carbonates like magnesium carbonates, iron carbonates. These are the few salts which causes the water alkaline. So alkalinity can be defined in a simple way. It is a acid neutralizing capacity of water. So that is a alkalinity. So, in a more correct way, we can define the as alkalinity as alkalinity of water is defined as the concentration of alkaline substances such as hydroxides, bicarbonates, and carbonates present in the water. And as we discussed, the examples of the salts which causes the alkalinity to the water sample. If you compare the strength of the bases like hydroxides, carbonates, and bicarbonates, in that the hydroxides are more stronger base than the carbonates, which are more stronger base than the bicarbonates. So this alkalinity causing salts make the water unsuitable for the use for the domestic as well for the industrial purpose. The alkaline water, if we use for the boiler for the steam generation, then it causes the caustic embrittlement, and therefore removal of alkalinity both in qualitative and quantitative way is very important to avoid the troubles in the boiler. So let us discuss how to determine the alkalinity. Alkalinity can be determined by using the acid-base titration. Here the water is considered as a base or basic in nature, and we can titrate it with the standard acid solution. Based upon the indicator used for this titration, there are two types of alkalinities are there. As the phenolphthalein indicator is used, the corresponding alkalinity is called as the phenolphthalein alkalinity, and the methyl orange indicator is used to determine the alkalinity. That alkalinity is called as the methyl orange alkalinity. So let us discuss the procedure to determine the alkalinity of water sample. For that, you have to fill the burette by the standard strong acid solution with concentration let us Z. Here we can use the HCl as well. You can use the H2SO4, but mostly the HCl is used for the titration. Then pipette out fixed volume of water sample, let us V volume in a conical flask, and then into the water sample add 2 to 3 drops of phenolphthalein indicator. Then the water sample becomes pink in color. Then titrate this pink colored solution with the standard strong acid solution from the burette, drop by drop addition, till the pink color changes to colorless. Then record the endpoint of the titration. Let us this burette reading as considered as a V1 ml. Here the V1 ml of acid corresponds to the complete neutralization of hydroxide ions present in the water and half neutralization of carbonate ions present in the water. The alkalinity due to the hydroxide and carbonates and whose neutralization can be indicated by the phenolphthalein indicator is called as a phenolphthalein alkalinity, and it is denoted by P. The reactions taking place during this alkalinity neutralization is represented in the next slide. Then into that colorless water sample, add 2 to 3 drops of methyl orange indicator. Then the color of the sample becomes colorless or it may be slightly yellowish. Then continue the titration with a stronger acid from the burette till the color changes to orange or red. Consider that reading as a V2 ml. This V2 ml of volume of acid corresponds to the complete neutralization of bicarbonate ions present in the water, and in this way the bicarbonates are converted into the water and liberation of CO2 takes place. So in this way, all the alkaline substances present in the water or alkalinities present in the water is neutralized by using the acid, and the corresponding volume of acid is noted down. By using this data, we can derive the formula to calculate the phenolphthalein alkalinity, which is indicated by the P, and the methyl orange alkalinity, which is indicated by the M. So what is methyl orange alkalinity as we discuss here? The alkalinity obtained due to the complete neutralization of bicarbonates and whose neutralization is indicated by the methyl orange indicator is known as methyl orange alkalinity. Reactions are given here, my friends. In the first, V1 ml of acid corresponds to hydroxide, complete neutralization of hydroxide, and half neutralization of carbonate ions as shown in the reaction. And V2 ml of acid corresponds to the neutralization of bicarbonate ions. Here, the bicarbonate ions are originally present in the water and which are formed during the neutralization of phenolphthalein alkalinity, that also HCO3 forms, and in that way the original bicarbonates and formed bicarbonate in the above reaction is neutralized in the final reaction, that is in the V2 ml of acid corresponds to that bicarbonate neutralization. So V1 and V2 we know the concentration of acid, we know the volume of water sample taken for the titration. Based upon that, we can derive the formula for the phenolphthalein alkalinity and methyl orange alkalinity. So P is equal to, that is phenolphthalein alkalinity is equal to V1 into Z into 50 into 1000 divided by P, ppm CaCO3 equivalent. Here, dear friends, V1 is the volume of acid required for the neutralization of the phenolphthalein endpoint. Z is the concentration of acid. 50 is the equivalent weight of CaCO3. 1000 is the conversion factor, and V is the volume of water sample taken for the titration. By this way we can calculate the P, then we can calculate the M. The remaining things are same. Here only the change is in the V2, that is the volume of acid required for the methyl orange endpoint. V2 into Z into 50 into 1000 divided by V, ppm CaCO3 equivalent. Dear friends, it is always not necessary to have all the alkalinities together to exist in the water sample. Sometimes different types of alkalinities may exist in the water sample. So these are the types of alkalinities. Water may contain only hydroxide alkalinity, water may contain only bicarbonate alkalinity, water may contain only carbonate alkalinity. Sometimes in the water, the two alkalinities like hydroxide and carbonate may occur together, or carbonate and bicarbonate may occur together, but the remaining alkalinity, that is the hydroxide and bicarbonate alkalinity, does not exist together. OH minus ion and HCO3 minus ion alkalinity does not exist together, because when these two alkalinities come together, there is a reaction between them and there is a formation of carbonate alkalinity, which is already considered, and therefore that type of alkalinity does not exist together. Once you know the P value and M value, dear friends, you can calculate the individual concentration of hydroxide alkalinity, carbonate alkalinity, and bicarbonate alkalinity in ppm. So for example, here by using this table you can calculate, you have to compare the values of P and M, and then you have to use the corresponding situation to calculate the P and M. For example, let us see, if the V1 is equal to V2, that is value of P and value of M is same or equal, then the concentration of hydroxide alkalinity will be P, concentration of carbonate alkalinity will be 0, and concentration of bicarbonate alkalinity will be 0. So in this way you have to compare the values of V1 and V2 P and M, and you have to find out the individual concentration of alkalinities present in the water sample. So this is about the determination of alkalinity from the water sample by using the acid-base titration, which is also called as the neutralization titration. So based upon that, dear friends, the numericals are asked in the examination, and here are some numericals are taken, discussed, we are going to discuss how to solve the numericals based upon this. So first problem, 100 ml of water sample requires 4.3 ml of 0.02 normal HCl up to phenolphthalein endpoint and total 11.9 ml up to methyl orange endpoint, full stop. Calculate the type and amount of alkalinity present in the water sample. So see here, the solution. The given things are there in the numerical are volume of water sample, V1, V2, concentration of acid, that is the Z. Based upon that, you have to calculate the P and M. For example, 100 ml of water sample. So here, volume of water sample is a 100 ml, that is a V. 4.3 ml of, that is a V1. 0.02 normal HCl, that is a Z, that is the concentration of acid. So by using this data, you can calculate the P. So what is the P? P is equal to V1 upon V into Z into 50 into 1000. So V1 is the 4.3, V is the volume of water sample 100, Z is the concentration of acid 0.02 normal, and the remaining is the given things 50 into 1000. So if you put these values and if you calculate it, we will get the answer. Then to calculate the M, acid is same, so concentration is same, water sample is same, so volume of water sample is also same, that is V is same, Z is same, only difference is in the V2. So you have to consider the V2 here, total 11.9. So you have to consider the methyl orange endpoint V2, that is 11.9. So for the M, you can write down V2 upon V into Z into 50 into 1000. V2 is 11.9. Rest of the things are same as in the P. So 11.9 into divided by 100 into 0.02 into 50 into 1000, you will get the answer 119 ppm CaCO3 equivalent. Now you have to compare the value of P and M. If you compare the value of P and M, you will find that P is less than 1 half of M. Is P is equal to 0? No. If P is equal to M? No. Is P is equal to P is greater than 1 half of M? No. So the condition fulfilled by comparing the value of P and M is here P is less than 1 half of M. So if you compare here the table, P is less than 1 half of M, P is less than 1 half of M here. Last condition, so here the OH minus ion concentration will be 0, carbonic ion concentration will be 2P, and bicarbonate ion concentration will be M minus 2P. So you have to put the value of P and M here, you will get the concentration of individual alkalities. So see here, OH minus alkalinity is 0, so it will not consider. CO3 2 minus ion is 2P, so here 2P is equal to 2 into 43, you will get the 86 ppm CaCO3 equivalent, and you have to calculate the HCO3, that is the bicarbonate alkalinity, and the formula the concentration is M minus 2P. So 119 minus 86, you will get the 33 ppm CaCO3 equivalent. So in this way, we will calculate the types and amount of alkalinities present in the given water sample. The problems are very simple, they are straightforward. You have to just find the values of volume of water sample, phenolphthalein alkalinity endpoint, that is a V1, methyl orange endpoint, that is a V2, and concentration of acid, that is a Z. If you know these things, you are easily calculate the P and M. Let us have the second problem. You try to solve it by taking the reference of first problem. So here a water sample is non-alkaline to phenolphthalein indicator. However, 100 ml of the water sample on a titration with 0.02 normal H2SO4 requires 14.5 ml of the acid to obtain endpoint using methyl orange indicator to identify type of alkalinity and determine its extent. So here, dear friends, the problem itself indicates the sentence given in the problem. A water sample is not alkaline to phenolphthalein. It means the water sample does not show pink color on addition of phenolphthalein indicator into the water sample. It indicates the absence of phenolphthalein alkalinity. So water sample contains only methyl orange alkalinity. So here you are going to write down the calculate directly to the M, but you have to write down about the P, because that 50% answer you have to write here about the P. Water sample is not alkaline to phenolphthalein, what it indicates. You have to write the answer for that value first, and then you have to calculate the M. So here M is V2 upon V into Z into 50 into 1000 ppm CaCO3 equivalent. What is V2 here? So directly you have to take the 14.5 ml because V1 is 0. Then V is the volume of water sample 100 ml into Z, concentration of acid 0.02 normal, and then 50 into 1000. If you calculate this, you will get the 145 ppm CaCO3 equivalent, that is M alkalinity. So as the water sample is not alkaline to phenolphthalein, only M is present, and that is the 145 ppm CaCO3 equivalent. In this way, dear friends, we can solve the problems. For that, you must know the formula and you must know what data you have to collect from the problem. By reading the problem, by understanding the problem, if you put the values in the P and M, you will get the answers. Third example, try to solve this example without looking into these PPTs. Try by your own and you will get the answers. For the more practice, I'm given here the two problems for the more practice to make that more understanding of that alkalinity determination. And dear friends, you can comment your answers in comment box and enjoy the learning. If you have any doubt, you can comment me. If you have any questions, any doubts, you can comment me. Thank you very much.